Right, so all these guys are
Are
right.
you really putting it on this company?
I did 1 month.
Okay.
What?
They bring 100% whole grain.
So there's ours. It's literally just corn and oil.
Okay, if we have time, we'll come back and do that bell ringer, but for the second time, we will not.
You did notes yesterday. Hey, so Bible notes?
Wow, okay, fine.
Daniel.
That wasn't notes, though. We just talked about Daniel.
You know our cheese is named
At some point. I'm not in a place that I really. Okay. So, did you guys know that Newton's gravitation is the reason why we have ocean tides?
Yes.
Right about that.
Yeah, it's great going ahead because now you actually have
Right stuff.
Okay, high and low tides are partly due to gravitational forces on Earth and the Moon. Actually, they're predominantly due to the gravitational force between Earth and the Moon, but there is also an effect that the Sun has on high and low tides as well. I got a little video here that I'll show you, a little 3-minute video. The tides result from the difference between the gravitational force on our surface and at the center. So let's see here.
A tsunami is caused by
It's like when the earth shakes real hard.
Dude, the earth shook one time so hard, the entire world flooded.
Hey there, I'm Josh Clark with this brainstorm. I want you how the tides work. Have you ever seen somebody buried up to their neck in sand on the beach, and then the tide slowly comes in and they drown? And well, next time you'll know, and you can explain it to them as they wait to die. We need to be very careful here because as Princess Francois study drown.
No, beginning.
How the tides work. Have you ever seen somebody buried up to their neck in sand on the beach, and then the tide slowly comes in and they drown? And I wonder how tides work. Well, next time you'll know.
I like this guy.
We need to be very careful here because, as French astronomer Francois Arago once said, studying the tides is the tomb of human curiosity, which means it can break your brain, as you'll see. There's a lot of factors involved in creating the tides here on Earth, but the big three are the Moon, the Sun, and the Earth. The gravitational pull of all three of those bodies interacting creates the tides. The biggest factor actually is the Moon. It exerts about 2.2 times more power on the tides than the Sun does. So for once, the Moon gets to one up the Sun. It's kind of a big deal to it. Imagine for our purposes the Earth is right here and the Moon is directly above it. Now, they exert a gravitational pull on one another, and since on the Earth most things are pinned down, we have shoes, buildings have foundations, stuff stays in place. But the oceans, being literally fluid, actually can be pulled toward the Moon, and this is what creates the tide. The Moon's here, it's pulling on the ocean at the top of the Earth, creating a high tide on the top. Now on the bottom, another high tide is created because the Earth itself is pulled toward the Moon, even though the oceans down here have less gravitational pull exerted on them, being farthest away from the Moon. So on the top and bottom, you have high tide because of the tidal bulges, and on the sides that are at right angles to the Moon, you have low tide because the ocean's stretched thin over the surface of the Earth. Pretty crazy, huh? So, like I said, the Sun also exerts an influence on the tides, but it's less pronounced than the Moon. See, it actually enhances or diminishes the gravitational pull of the Moon here on Earth. When the Sun and the Moon are in alignment, the Sun enhances the Moon's gravitational pull, creating higher tides than normal. They're called spring tides, and they happen on a full moon or a new moon. Now, when the Sun and the Moon are at right angles to one another, with the Earth right about here, the Sun diminishes the gravitational pull of the Moon on Earth, creating lower than normal high tides, also called neap tides. These happen on the quarter moon. Because the Earth and the Moon are constantly moving and moving around one another, there's a constant movement from high tide to low tide. Twice a day, you get a high tide in most places. usually
that?
once every 12 hours and 25 minutes.
Say?
But this can vary, and in some places only see a high tide once every 24 hours. Those are called diurnal tides. So this is a daily occurrence, actually twice daily in most places. But tidal waves, even though they have the word tide in them pretty much, but without the E, they're not related to this gravitational push and pull. They're usually the result of earthquakes. So that's tides.
Yeah. There actually is about two high tides every day. The only reason I know that is because I like to fish.
Yes, the high tide is
And
it's just because like a bunch of people are.
very possible. Okay. Hey, no. Let's finish here. So really, what ended up happening, okay, is there's your Earth, there's your Moon. It said that there was bulbs there. I gotta be careful, make sure that's not the bulbs there. Okay. And can anybody explain why there would be a bulge on the top?
Yeah, I get the top part, the bottom
The
part.
top part's the easiest, right? Because this is where is the strongest gravitational force on that Earth, is right there. Okay? Well, this is where the weakest pull is.
So it's driven
not
down.
it's not that it's pulling this way, it's that it's not being pulled that way.
So it's driven.
Catch it.
You're listening to me. Okay, so what ends up happening is the closest part has the strongest gravitational force, so you get the bulge, and the bottom part gets the bulge only because it's
Percy Jackson.
Okay, no, you just completely interrupted him. Let's keep going.
It's almost the opposite reason. It's not that it bulges, it's that it's the weakest force is there, and so what ends up happening is it doesn't say.
The ocean sound.
I thought of it that way. That's kind of good to say.
Am I in philosophy?
It actually kind of works.
Oh, yes.
So weird.
I created a theory. Like sagging
Because it's
ocean.
bulge, it's the furthest away from the moon, and so it's not getting pulled up. It's getting pulled up the least here than any other place on Earth. And so because of that,
Don't you hate when you have saggy water?
what?
Don't you hate it when you have saggy water?
favorite variety.
All right.
Like red water like that. It's too soggy.
It's just water way too soggy.
we should
Water's way too moist. The black hole section.
That was actually really good.
Cavendish.
And we should watch it next time.
Okay. So there's this whole thing about Cavendish and this. I watched a little YouTube video on him. Sounds to me like this guy had some serious social problems. Like he went to like some really prestige college, and then right before he had to like give his dissertation or something, he was so scared to give it they just ran away. And he never even, he was like, he was so scared of females that he never had a conversation with females. But, yeah. And
Parents, you literally are married.
Never once though.
Never talked to her.
we never talked.
It's got awkward silence.
Who was that?
Who was it?
Why? I didn't count how many times the name fart. It's unhealthy.
I don't know why everyone heard that.
We're not, there's very little I'm going to make you know about Cavendish. If you did some reading, it talked a little bit about an experiment that he did. And it's kind of interesting, but it is really difficult and complicated. It's getting to the point where I don't think I have a great understanding of it. But essentially what he did was he made this apparatus with really big like metal balls, and then he essentially like wanted to see how these two spherical objects would attract each other, but he had to be able to do it without himself being close enough to affect it, right? Because technically there would be a gravitational pull that he would have on those spherical objects as well.
I've seen these.
Sort of like in outer space.
Yeah.
And so like he had to like leave a hole in his leave a small hole in his experiment and like look from a long ways away. It was really kind of goofy. So I'm not gonna make you know a whole lot about it, but he was the one who kind of came up with that kind of confusing experimental constant G. And even to be honest, I'm not 100% sure how that all works, so I'm not gonna make you know all that. So,
Or in advanced physics.
yeah, if I have to teach advanced physics, I'll figure it out. Okay, gravity is a field force. Remind me what a field force is. No contact, no touching.
All touchy.
Okay?
That's maybe yes.
Give me some other examples of field forces.
Gravity.
Electric,
Magnets.
forces.
You would think like wind is touching things, so it would not be.
Good job.
Stop.
Okay?
Yeah.
What about
Gravitational
the,
field
energy
strength. We'll
field
talk
in
much
general?
more about field strength when we get into magnets and electricity. Okay?
Or the sound is no sound. It's just pressure we're sitting.
Yeah. Yeah, acoustic is just, anyway, we'll get into that when we get into that. Okay? The gravitational field G is the vector with magnitude G that points in the direction of Fg. So gravitational field strength equals your free fall acceleration. Your 9.81 meters per second squared. Okay? And this is just showing, this little visual is just showing the closer you are to the object that has a gravitational force on you, the stronger the what?
The force.
I feel like we've already talked about weight before, but why not? What is the symbol for weight?
Is it divided by kilogram?
Not unit. What is the symbol?
Oh,
Symbol for weight.
newtons per kilograms of mass.
That's a unit. What is the symbol?
No, it's not W. It's
Pounds.
I don't want W. W is
M.
cheap version of it.
N. N-O-P. Q-R-S.
Oh, that's what you wanted?
Oh yeah, I totally do that.
Oh,
that's
Remember
You wanted the
that
symbol.
weight
Is the force.
Oh.
is the force of gravity.
Yeah, but like
Multiple
symbols.
Oh,
No, it's
Graves.
one symbol. One symbol.
Graves, I didn't know you wanted the symbol.
Alright. Because it depends on gravitational field strength, weight can change. How many times? I feel like I talked about this every year.
Yeah, I think you do.
You've already talked about
Also, what's the point of this middle one? Is it any use at all?
Wait a second.
That's the third one in the
Yeah.
I literally did not even fart. I literally did not.
Yes, we're like, why is no one reacting? They got so loud, so like dead silent. No one turned to head. I'm like, okay.
Okay, so
Oh.
Fg equals mg. You should be familiar with that.
What do you say about non-productive digestive systems?
On the surface of any planet, the value of G as well as your weight will depend on the planet's mass and its radius. Why did I think that door opened?
It's heard something.
That door is.
Oh, okay.
Well, they say we're doing all three of those.
I mean, only two of them. The middle one just showing you how to get to the third one.
Yeah, essentially.
basically just like plug that in.
So it's basically taking this gravitational equation and this one, simply setting them equal to each other. If that makes sense. It's taking FG and FG and substituting it in and figuring out how G relates, little g relates to big G essentially. Well. So if you brought this over, this would be mg. That would cancel out. So mg equals.
Well, what's the last? So we have to write that whole thing on
I'm trying to remember what the real significance of this equation is.
It's the mass, you get gravity, you can get Earth's weight. Does that mean?
Oh, yeah. So what this is trying to say is you can get any particular weight from that. In this particular situation, it's talking about Earth weight.
So we don't need this on the board.
Well, there's a lot.
It kind of already is on there, just in a different form.
Oh yeah, on that, it's a capital E, but on here, it's a lowercase e. And so when I looked up what lowercase e is, it's electron mass.
Yeah. So
Stop.
And so I was like, okay,
That's the mass of Earth.
yeah. Yeah. I split it up quick.
Yeah, we were so confused.
We've gone from planets to times 10 to the negative.
Yeah, so if I remember right, what that's trying to show you is how they were able to figure out the Earth's mass using what?
It's like 5.98.
Even here it's talking about the Earth's mass. What?
I kind of want to put like a patch on my
What?
on this jacket.
Actually, we're gonna ask if we're about to launch a satellite.
Like a big